Perhaps the most profound impact of the Western Interior Seaway wasn't what evolved within it, but how it transformed the land it divided. By splitting North America into two island continents, it created what biologists call island isolation, the perfect conditions for rapid, divergent evolution. Larimedia, the western landmass, developed its own unique dinosaur fauna, characterized by giant sauropods, heavily armored ankylosaurs, and massive ceratopsians like Centrosaurus. The tyrannosaurs here evolved toward maximum size and power, with thick skulls and bone-crushing bites. Meanwhile, on Appalachia to the east, a completely different evolutionary path unfolded without the pressure from giant tyrannosaurs. Smaller predators like the Dryptosaurids flourished, developing longer, more dexterous arms with enlarged claws. Hadrosaurids became more diverse here, while ceratopsians remained rare. Most surprising of all, recent fossil evidence suggests the presence of at least one Carcharodontosaur, a family of predatory dinosaurs previously thought to be extinct in North America by this time. This raises a stunning possibility that isolated island evolution preserved species that had disappeared elsewhere, creating a sort of lost world where presumed extinct lineages continued to thrive. The Seaway hadn't just divided a continent, it had created two parallel evolutionary experiments. By around 70 million years ago, the Great Seaway began its retreat. It didn't happen overnight. It was a gradual withdrawal that would take millions of years. The same tectonic forces that had created the basin now worked to uplift the land, slowly pushing the seafloor above the waterline. As the sea receded, it left behind something unexpected: incredibly fertile soil, rich with marine sediments and organic matter. The former seabed became a blank canvas for new life, but one conditioned by the chaos that had preceded it. The climate was changing, too, becoming more seasonal, more unpredictable. In this transitional zone, a new ecosystem emerged, one that would become legendary in paleontological circles: Hell Creek. Stretching across what is now Montana, Wyoming, North Dakota, and South Dakota, this region transformed from seafloor to swampland, from ocean depths to floodplains, dissected by rivers and dotted with lakes. It should have been paradise. Instead, it became something else entirely: the most competitive, savage, and dangerous terrestrial ecosystem ever to exist on Earth. At the apex of this new hell stood the most infamous predator in Earth's history, Tyrannosaurus rex. But forget what you think you know about this animal. The T-Rex of Hell Creek wasn't just big, it was an evolutionary perfect storm of predatory adaptations. The largest specimens approached 12.5 tons, making them potentially the heaviest predatory dinosaurs ever to walk the Earth. Their bite force exceeded 60,000 newtons, enough to shatter bone into fragments. Recent studies of their teeth reveal serrations optimized not just for cutting flesh but for drilling through bone, allowing them to access nutritious marrow other predators couldn't reach. Most chilling of all is what paleontologists call puncture pull feeding. T-Rex didn't just bite. It anchored its teeth in prey and then pulled backward, ripping away chunks of meat and bone in a single motion. Coprolite fossil feces analysis reveals bone fragments pulverized so completely they resembled sand. And despite their massive size, biomechanical studies suggest they could reach speeds of up to 20 miles per hour, not cheetah fast, but more than quick enough to ambush prey or run down slower animals. The idea that T-Rex was a scavenger has been thoroughly debunked. This was the ultimate predator, capable of killing anything that shared its environment. And what's most surprising, it wasn't even rare. Fossil evidence suggests T-Rex was the second most common dinosaur in Hell Creek, with 85% of all known specimens coming from this single formation. The predator wasn't just present in this ecosystem, it dominated it. But T-Rex wasn't the only nightmare stalking Hell Creek. A controversial smaller tyrannosaur, Nanotyrannus, has divided paleontologists for decades. Some believe it represents juvenile T-rex specimens, while others maintain it was a separate species. Smaller but faster, more agile, and potentially hunting in packs. What's not disputed is that specimens attributed to Nanotyrannus show adaptations for speed over power, with longer, more slender legs and proportionally larger eyes, suggesting they hunted differently than adult T-Rex. Then there were the raptors, not Velociraptor, which never lived in North America, but equally terrifying dromaeosaurs, like Acaraptor and Decatur. The latter is particularly disturbing at nearly 20 feet long and weighing as much as a grizzly bear. It combined raptor agility with unprecedented size. Its killing claw measured 9 inches from base to tip, designed not just to puncture but to open massive wounds with a single kick. Recent analysis of its flexor tubercle, the attachment point for claw muscles, indicates it may have had the strongest slashing capability of any known dromaeosaur. While some paleontologists debate whether Decaturaptor is a composite of multiple species, the individual bones are real, and they paint a picture of a predator, specifically evolved for inflicting catastrophic bleeding injuries. Whatever form these secondary predators took, they ensured that even if you somehow avoided T-Rex, death still stalked you from every direction. What truly set Hell Creek apart wasn't just its predators. It was that even the herbivores were built for combat. Triceratops, far from being a passive plant eater, was one of the most aggressive animals in the ecosystem, weighing up to 10 tons and armed with 2 forward-facing horns exceeding 3 feet in length. It was capable of fending off even T-Rex attacks. In fact, Triceratops is the only dinosaur with direct fossil evidence of having injured a T-Rex, with one specimen showing a horn puncture that had begun to heal before the predator died. Analysis of Triceratops skulls shows that 14% bear signs of combat damage, not from predator attacks, but from fighting each other. These weren't defensive skirmishes, they were all-out battles for dominance. Then there was Ankylosaurus, the tank of the dinosaur world. Its armor consisted of bony plates wider than dinner plates, fused directly to its skeleton. But its most iconic weapon was its tail club, a fusion of bone and keratin that recent studies suggest could be swung with the force of 1,000 baseball bats combined. Mechanical studies indicate this force was sufficient to shatter a T-Rex femur on impact. Tellingly, very few Ankylosaurus specimens show evidence of successful predator attacks. They were simply too dangerous to hunt. Even Edmontosaurus, a hadrosaur often portrayed as a dinosaur prey species, was a multi-ton beast capable of running at high speeds and delivering powerful kicks. Their fossil record suggests they traveled in massive herds that would have made predator attacks extremely risky. In Hell Creek, even the prey could kill you. The concentration of biological firepower in Hell Creek extended beyond the headline. Species, Pachycephalosaurs, the dome-headed dinosaurs reached their evolutionary peak here, with specimens showing cranial thickening that would have allowed them to deliver devastating headbutts. Multiple fossils show evidence of cranial trauma, suggesting these weren't just display structures, they were actively used in combat. Struthiomis, an ostrich-like theropod, wasn't a predator, but could reach speeds approaching 50 miles per hour, making it nearly twice as fast as the fastest human ever recorded. Even the birds weren't ordinary. Avosaurus, whose name literally means bird lizard, represents some of the largest avian dinosaurs of the time. Below the dinosaur-dominated canopy, smaller nightmares evolved. Paleosaniwa, a relative of modern Gila monsters, grew to sizes rarely seen in lizards before or since. With teeth eerily similar to modern sharks, designed for slicing rather than crushing, the waterways teemed with crocodilians, making even drinking a potentially fatal activity. But perhaps most surprising was Infranadraco's pterosaur, literally dragon from hell, a giant oozdarch previously confused with Unlike most pterosaurs that primarily fished, This monster is believed to have stalked the landscape on foot, using its massive beak to swallow smaller prey whole. Standing on its knuckles, it would have towered over a human, with a head larger than a man's torso. Hell Creek wasn't just an ecosystem, it was an arms race, frozen in time. In 2021, paleontologists announced a discovery that defied conventional understanding. A massive mosasaur, estimated at 36 feet long, with some liberal estimates suggesting up to 49 feet, found in Hell Creek Formation sediments. This shouldn't have been possible. Hell Creek was supposed to be a terrestrial environment, formed after the Western Interior Seaway had retreated. So how did a giant marine reptile end up buried alongside T-Rex and Triceratops? The implications have sparked fierce debate in the scientific community. Some researchers propose that this represents a population of mosasaurs that adapted to brackish or even freshwater environments, pushing inland along river systems as the seaway receded, effectively invading the terrestrial realm. Others suggest it was a lone individual that somehow became stranded in an inland water body, separated from the retreating sea. But the most intriguing hypothesis challenges our understanding of the seaway's retreat itself. It started as a question that no paleontologist could answer, a bizarre anomaly that shattered every theory about prehistoric North America. In 2021, researchers found something impossible beneath the Badlands of Montana. The remains of a sea monster. Not just any sea monster, but a 36-foot mosasaur, a marine reptile that should never have been there. You see, this wasn't ocean floor. This was Hell Creek, the deadliest ecosystem ever to exist on land. A place where T-Rex and Triceratops ruled as kings. So how did a monstrous marine predator end up buried in what was supposed to be dry land? The answer revealed something far more terrifying than anyone expected. A forgotten chapter in Earth's history, where a sea didn't just disappear, it transformed into something worse. The waters didn't just recede. They left behind a crucible of evolution, so extreme, so perfectly designed for creating monsters, that scientists now call it the most dangerous place that ever existed. This is the story of how one deadly sea gave birth to an even deadlier land, and changed the face of North America forever. Imagine standing on the shores of North America 100 million years ago. The continent you'd see wouldn't be the one we know today. From space, its outline might look familiar, but on the ground, chaos reigned. Two tectonic plates were grinding against each other in a geological battle that would reshape the continent. Mountains were being born, volcanoes erupted with terrifying regularity, and the land itself warped and buckled under immense pressure. But these violent birth pangs were just setting the stage for something far more sinister. As the plates collided, they created something unexpected, a massive depression, a basin running vertically through the heart of North America. In any other time, this might have been just another geological footnote. But Earth was experiencing one of its warmest periods ever recorded. The poles had little to no ice. Sea levels worldwide were rising dramatically. And this basin, this wound in the continent, was about to be flooded. It began with a trickle. Arctic waters spilled down from the north, while the warm Gulf of Mexico crept up from the south. The two bodies of water moved like slow-motion predators, devouring plains and forests, erasing ecosystems that had existed for millions of years. When these waters finally met in the middle, they created something unprecedented, the Western Interior Seaway. This wasn't just any sea. At its maximum extent, it stretched over 2,000 miles long and nearly 1,000 kilometers wide. But here's where it gets strange. Despite its massive footprint, the seaway was shockingly shallow, averaging only 760 meters at its deepest points. For comparison, that's barely a third of the depth of today's Mediterranean Sea. This peculiar shallowness would turn out to be the most important factor in what happened next, the creation of the most terrifying marine ecosystem Earth has ever known. A place that would earn the nickname Hell's Aquarium. But why would shallow water create monsters? The answer lies in the unique properties this depth created. Sunlight could penetrate almost the entire water column, triggering explosive growth of algae, plankton, and coral. Oxygen levels remained high throughout. Temperatures stayed warm from surface to seafloor. This wasn't just a habitable zone, it was supercharged. Every inch of this seaway became productive in ways that modern oceans can only achieve in their narrow continental shelves. Now add to this another critical element. The seaway had effectively split North America into two island continents, Laramida to the west and Appalachia to the east. The runoff from both landmasses dumped nutrients, minerals, and organic matter into the seaway, further enriching its waters. It was like injecting steroids directly into an ecosystem. The shallow basin created lagoons, marshes, deltas, and reefs. Countless specialized habitats packed densely together. No modern environment comes close to this concentration of biological opportunity. And where opportunity exists in nature, predators evolved to exploit it. The first to rise to dominance were the Mosasaurs, marine reptiles that would make today's great white sharks look like goldfish. The most famous, Mosasaurus hoffmanni, grew to lengths of over 50 feet, with a skull larger than a grown man and teeth that could slice through bone as easily as flesh. But what's often overlooked is that Mosasaurus wasn't even the most common apex predator. That title belongs to Tylosaurus, nearly as large, but potentially more aggressive, with specialized ram-like projections on its snout believed to be used for stunning prey before delivering a fatal bite. These weren't sluggish, cold-blooded reptiles, as once thought. Recent studies of their bone structure suggest they maintained elevated body temperatures and could move with explosive speed when attacking. Most terrifying of all, fossil evidence indicates they weren't picky eaters. They consumed everything from fish to birds to other marine reptiles, including smaller mosasaurs. Cannibalism wasn't just common, it was a survival strategy. But as apex predators multiplied, they created something rarely seen in nature: competitive equivalence at the top of the food chain. While mosasaurs claimed their territory in the seaway, another group of predators refused to cede dominance: sharks. These weren't just any sharks, but hypercarnivorous species with specialized teeth and hunting strategies that would make modern sharks seem tame by comparison. Some genera evolved to sizes exceeding today's largest great whites, with fossil teeth suggesting jaw sizes capable of swallowing a human whole. What made these sharks particularly deadly was their speed and agility compared to the larger mosasaurs. Where a mosasaur might rely on raw power, these sharks used precision and overwhelming numbers. Evidence suggests they may have engaged in pack hunting behaviors that allowed them to target even the largest prey. In certain regions of the seaway, shark teeth outnumbered mosasaur remains, indicating zones where sharks actually dominated as the apex predators. But the true horror of the seaway wasn't just that it created monsters. It created monsters that competed with each other, driving each species toward more specialized killing adaptations. And the nightmare didn't end with reptiles and sharks. From the depths of the seaway emerged something straight from maritime horror: the largest cephalopod ever to exist. Parapasosia, weighing up to 1.5 tons, dwarfed even the modern colossal squid, with tentacles thick as tree trunks and a beak powerful enough to crack the shells of ammonites. This creature represents one of the most unsettling evolutionary paths ever taken. Unlike modern squid that rely primarily on soft-bodied prey, Parapasosia appears to have had specialized appendages, capable of grasping and immobilizing large, struggling animals. The implications are chilling. While a modern giant squid might avoid large predators, Parapasosia potentially hunted them. But even this titan wasn't the end of the seaway's deadly innovations. Xephactinus, a fish growing to nearly 20 feet, possessed a grotesque appearance and hunting strategy, with fang-like teeth and a hinged jaw that could unhinged to swallow prey whole. It became the nightmare of the middle depths. One fossil specimen was found with an entire 6-foot fish preserved inside its stomach cavity. Evidence it died from the gluttony of its final meal. The seaway wasn't just creating individual monsters. It was creating an entire food web of them. The terror didn't stop at the water's edge. The rich bounty of the seaway attracted predators from above and created opportunities for new hunters. Along its shores, pteranodons, with wingspans exceeding 20 feet, circled above in numbers that would darken the sky. They weren't just scavengers, they were precision hunters, capable of spotting fish from hundreds of feet up and diving with calculated accuracy to snatch them from the water. Fossil evidence shows their bones were hollow, yet remarkably strong, optimized for the stress of impact when hitting the water at speed. But even more frightening were the creatures that patrolled the boundary between land and sea. Deinosuchus, often described simply as a giant crocodile, fails to capture the true horror of this 8-ton ambush predator, with armor plating thick, enough to withstand attacks from large dinosaurs, and a bite force estimated to exceed that of any living animal. This beast turned shorelines into death traps. Fossil evidence includes dinosaur bones bearing distinctive Deinosuchus bite marks, confirming what many paleontologists suspected: these weren't just fish eaters. They actively hunted terrestrial dinosaurs that came too close to the water's edge. The reign of Hell Creek's titans came to an abrupt end 66 million years ago, when an asteroid the size of a mountain slammed into what is now the Yucatan Peninsula. The impact released energy equivalent to 10 billion Hiroshima bombs, triggering global wildfires, acid rain, and a nuclear winter that blocked the sun for years. In a cruel twist of evolutionary fate, the very adaptations that had made Hell Creek's inhabitants so formidable, their size, their specialized hunting strategies, their high metabolic rates, now worked against them. Unable to find sufficient food during the prolonged darkness, unable to adapt quickly enough to the rapidly changing environment, they perished. The most competitive ecosystem ever to exist on land was erased almost overnight. When the dust settled and sunlight returned, a new world emerged, one dominated by the survivors, crocodilians, turtles, small mammals, and the descendants of the small, feathered dinosaurs we now call birds. The ultimate reset button had been pushed. Nature's most extreme experiment in predator evolution was over. Yet the story doesn't end there. The legacy of the Western Interior Seaway and Hell Creek continues to shape North America today. The rich marine sediments left behind by the retreating sea created some of the continent's most fertile farmland. The coal deposits formed from the swamps and forests of Hell Creek now fuel power plants across the nation. Even the oil and natural gas that power our modern world can trace their origins to the organic matter that once filled this ancient sea and the land it became. More profoundly, the geology of North America, its mountains, its plains, its river systems, still bears the imprint of this forgotten chapter. The Missouri River follows a path carved when the seaway first began to drain. The Rocky Mountains owe their final uplift to the same tectonic forces that closed the seaway for good. We live in a landscape shaped by these ancient events, walking daily across ground that was once the floor of Hell's Aquarium, and later, the hunting ground of history's most perfect predator. So the next time you drive across the Great Plains, look around and try to see beyond the wheat fields and prairies. Beneath your feet lies the grave of the most dangerous ecosystem Earth has ever produced. A place where evolution pushed the limits of what predatory life could become. A place where the sea didn't just retreat, it transformed into something even deadlier. The waters may have receded 66 million years ago, but they left behind something that changed the world forever. They left behind hell.